Welcome you all for the class of Reheat ranking cycle. In the previous classes, right from the beginning of the syllabus, we have seen what is basic steam power cycle on which it is running, and also we have seen the what is basic Rankine cycle. And in the previous class, we have seen the regenerative cycle. And in this class, we're going to see the reheat Rankine cycle. It is also modified Rankine cycle. The base things are Rankine cycle only, but by the small modifications, we getting some advantages in the ranking cycle. The read ranking cycle is designed to get the more specific work output to generate the required electrical power outputs in the power plants. In this class, I am going to explain what is the difference between the reheat and basic ranking cycle and working of reheat cycle and advantage of reheat cycle. In this slide, we can see this is a basic ranking cycle. Already we have seen the components of basic ranking cycle. All be familiar with the components of basic ranking cycle. Basic components of ranking cycle are boiler, turbine, condenser, and pump. In the basic ranking cycle, water will be converted as steam in the boiler, and then it will be supplied to the turbine. In the turbine, steam expands isentropically, and when steam is expanding in the turbine, turbine will produce work output. And then after that, steam will go to the condenser after the expansion. In the condenser, steam will convert into water. That water will be again pumped into the boiler by the pump. This is the basic working of the basic Rankine cycle. And here you can see the TS diagram, which is representing the sequence of process of a Rankine cycle. What are the sequence of process of Rankine cycle? That is, we can see in this slide, we are having the TS diagram of a Rankine cycle. In the TS diagram of Rankine cycle, 1 to 2 represents the pump work. In this pump work, saturated water or unsaturated water which is coming out of the condenser will be pumped to the boiler in the 1 to 2. And in the 2 to 3, that water which is coming from the condenser will be converted into the superheated steam. And 3 to 4, the superheated steam which is coming from the boiler will be isentropically expands in the turbine and produces the work output. After 3 to 4, the expanded steam will go to the condenser. In the condenser, again it will be converted as a water, and again it will be pumped to the boiler. This is the basic Rankine cycle. In the basic Rankine cycle, it consists of constant volume heat addition and isothermal expansion and isotropic expansion and isothermal compression. This is a basic Rankine cycle. But in the problem, we have one problem in the basic Rankine cycle. For example, when you uh, depute a multi-stage turbine in the power plant. For example, if you're using the turbine which is having the number of stages, the supplied steam to the turbine will be become wet after 2 to 3 stages. For example, let us say turbine is having 10 stages. 10 stages. What is the amount of steam supplied from the boiler in the manner of superheated will be expanded in the partial stage up to 1, 2, 3, 4, 5. And after some stages, the steam will become wet, and sometimes the steam will become condensated and become like a water. If this case happens in the uh, turbine, the wetness of the steam and the water, the condensed water, may ruin the components of turbine by the corrosion. If the wetness is there, what happens? The components of the turbine will be corroded and they may damage physically. This is the problem we are getting with the basic Rankine cycle. And one more problem also, when This steam is becoming wet in the partial expansion. After the partial expansion, in the further stages, steam is unable to give the required work output. If there is no required work output, the generator cannot generate the required power output from the generation. So, in order to avoid this particular problem, the scientists designed the reheat Rankine cycle. I will show the diagram of reheat Rankine cycle in this slide. In this slide, we are having the diagram of a reheat Rankine cycle here. In the reheat Rankine cycle, it is also same like the basic Rankine cycle, but here after the partial expansion, after the partial expansion, after the partial expansion, here you can see steam is again going into the boiler. After the partial expansion, when steam is becoming wet, again we are sending that particular steam into the boiler. Again in the boiler, the steam will be reheated. Again the superheat steam will be supplied to the turbine. By this, in the back stages also, by this reheating, we can assure highly sat highly saturated or super saturated in the final stages also. In the basic Rankine cycle, there is no reheating between the first expansion and the first stages of the turbine and last stages of the turbine. For the throughout stages, we are using the same amount of the steam. When you are using the throughout stages, same amount of steam, in the middle of the stages, there is a chance of getting wetness for the steam. By this, we get the corrosion for the components, and also we can get the lower work output. In order to avoid this particular problem, the reheat cycle is designed. In the reheat cycle, after the partial expansion, steam will again go to the boiler. Steam will again go to the boiler. It will be again reheated up to superheat level, and then it will be supplied to the further stages. By this, the workout will be good. Workout the specific work output will be increased. The specific work output will be increased by the reheat Rankine cycle. This is the advantage of reheat Rankine cycle. If you want to take the thermodynamical considerations for the reheat Rankine cycle, in the next slide we are going to explain the thermodynamical analysis of the reheat Rankine cycle. Thermodynamic analysis of the reheat Rankine cycle. Here we are going to see what is the thermodynamical analysis of reheat Rankine cycle. See, already we know that the basic what is happening in the reheat cycle. In the reheat cycle, we are having the boiler and turbine. And after the partial expansion, for example, this is a first primary turbine. If it is a secondary turbine, what is happening after the primary turbine? Again, steam is going into the boiler. Again, it is supplied to the secondary turbine. From here, it is coming to the condenser here. From the condenser, again, it is coming to the boiler. This is the scenario. Reheat cycle. For the thermodynamical analysis, for example, if you give the notations, for example, if you send in steam with H1 enthalpy into the turbine, H1 enthalpy into the turbine, H1 enthalpy into the turbine, and after the partial expansion will become the H2, and this H2 steam will go to the boiler, and after the heat it will become H3, and after the secondary turbine expansion it will become H4. Now, after the condensation, H4 becomes HF4, and before the boiler we are supplying HF4 heat here. If we want to take work done of a particular turbine, reheat turbine, that work done equal to, there are two expansions here. One is H1 minus H2 is the one expansion, and H3 minus H4 is another expansion. And two heat supplied will be there. One is H1 minus HF4 heat supplied, and second is H2 minus H3 heat supply. Second is H2 minus H3 heat supply. If you want to get the efficiency of reheat cycle, that is nothing but WT by heat supply. So it will be H1 minus H2 plus H3 minus H4 by H1 minus HF4 plus H2 minus H. This is the efficiency of reheat cycle. This is a reheat cycle. Thank you for listening. I am closing this particular class.